Hello, Mr. Wilford here. I just wanted to go through Chapter 5, Section 6 with you, and it's all about the quadratic formula in this section. We want to make sure that we use this formula when we're trying to find the roots or the zeros of a quadratic equation. It's very helpful for us. Of course, we have many ways that we've talked about and that we've used to solve quadratic equations before. By graphing, making tables, factoring, using square roots, and completing the square. The nice thing about this quadratic formula is that it's a formula, and a lot of people are used to using formulas, and basically we're going to be plugging in coefficients of the quadratic equation into this quadratic formula, and if we simplify it correctly, we should be able to get out our roots or our zeros. The key here is that we make sure that we have the quadratic formula or quadratic equation in standard form. And so here you can see here the quadratic formula ax squared plus bx plus c. This is in standard form. And the solutions or the roots are right here. This is the quadratic formula right here. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So that's a formula that you want to make sure that you write down and that you understand how to use. Here's an example of using the quadratic formula. First of all, this is written in function notation. Remember, think of this f of x as a y. So we have f of x, or y, equal to x squared plus 10x plus 2. First thing we want to do is set this quadratic equation equal to 0, and double check again that it is in standard form. So our x squared is first, our x term, and then our constant term is next. This is kind of nice because everything is color coordinated for us here. Our first coefficient with the x squared is really a 1, even though we don't write that, it's still there. So a is 1, b is 10, and c is 2. If any of these were negatives, we certainly would take that as a negative 2, for example. So anyhow, what we're doing now is we're just simply plugging in these coefficients, 1, 10, and 2, in for a, b, and c in their respective places. And then we have to be able to simplify it. So this is where everything is plugged in. Negative 10 plus or minus the square root of 10 squared is 100. Multiplying these together here gives me a negative 8. 100 minus 8 is 92. And then simplifying the radical and then actually simplifying the fraction gives me a negative 5 plus or minus the square root of 23. Some people will be able to actually use your calculator at this step right here and plug this into your calculator and get out some decimal answers that will be equivalent to what you see here, which is fine a lot of the times as well to get decimal answers. Again, you just want to be careful as you go through and you simplify this. Take it step by step, piece by piece. Don't try to do too much at once. Your calculator will do a lot of the work for you as long as you are punching everything in correctly. And then the rest of this here is just checking this answer by completing the square, and you can see we get the same answer out. So again, it's a nice formula for you to make sure that you remember and understand how to use and what it gets out for us. Here's just another example where you are plugging in the coefficients 2, negative 1, and 2 into the quadratic formula, and again you can see here simplifying through. This is an example where we end up with an imaginary number because of this negative 15. The other thing to remember is that we are actually ending up with two answers here because of the plus and the minus, so make sure you're aware of that as well. The last thing here is something called the discriminant, and the discriminant is actually part of the quadratic formula. It's this red piece right here, b squared minus 4ac. You can use the discriminant to determine what types of roots you have. If the discriminant is greater than 0, it's positive, you have 2 roots. If the discriminant is equal to 0, you have 1 root. And if the discriminant is less than 0, if it's negative, you have imaginary roots or non-real roots. If you have any questions, please let me know. Thanks.